All right, so let's back up. I apologize. Let me speak clearly as possible, even though it's late. It's true that we have two numbers, one number and two numbers, and the two numbers are multiplying and they make 33, right? So this is true. We have a times b and it equals 33. But what's not true is you can't say that therefore either a equals b or a equals 33 or b has to equal 33. That wouldn't be true, because they could be anything. They could be all kinds of stuff. That right here would only work if this was equal to 0. Because if you had two numbers and they multiplied to make 0, then one of them has to be 0. But if you have two numbers that multiply to make anything else, like 33, neither number has to be 0. It could be like 2 and 16.5, right? Neither one has to be 33. So you can't use that kind of like that shortcut, that logical shortcut right away. So what you need is this thing to equal 0. And so what we're going to do is we're going to subtract. And then we're going to try to see if we can solve that. Here's the problem. We want this. We want a times b equals 0. That's what we want. Right now we have a times b plus something equals 0. So this doesn't work either. We need to put this all together in one thing. So what we're going to do, I'm going to do it as scratch. I'm going to do it over here. I'm going to distribute this, right? I'm going to get x squared plus 8x minus 33 equals 0. Cool. Now I can factor that, and then I'll have two numbers multiplying that make 0. Because this would be x plus 11 and x minus 3 equals 0. Is that good? Yes, sir.
What if you put it the x minus 3's first?
Oh yeah, that's fine. No problem.
There's no problem how you put it?
Yeah, so if you wrote instead, you're saying, let me write it down just to make sure I understand what you're saying. You're saying, what if I wrote that, right? Same thing. Yeah, that would be like, this would be like a times b, this would be b times a. So x equals negative 11 or x equals positive 3. So what's the takeaway? So like sometimes I know people, like Alexa, I know you're frustrated, right?
Yes.
I think one of the things you're getting frustrated with factoring is each problem's a little different.
Yeah.
And you can't learn the problems specifically. You have to learn like the big idea.
Yeah.
So here's the big idea. We need to get something factored equal to 0. This is factored, that's true, but it doesn't equal 0. So the problem is we need this to be like one thing times another thing that equals 0. So we had to do a whole bunch of work to make that happen. And that's what's going to happen here too. So watch, here we're going to do this, watch out. Let's see if we can get the same big idea to help us answer this question too, okay? So the idea is that you want like two numbers or maybe even three numbers, but they're all multiplying to equal 0. Because once that's true, then you know that either a is going to equal 0 or b is going to equal 0. But that fact only works, that method only works if it's equal to 0. So we got to get this equal to 0. And that means we got to move everything to one side. So Ivan, we could move these things here to the left, or if we wanted, we could move these things here to the right. You get to choose.
Left.
You want to move these left?
Mm-hmm.
Okay. Oh, got all blurry. Now at the same time, because I don't want to waste like 14,000 pages on one problem. So at the same time, once this stupid thing focuses, what I would like to do is I'd also like to multiply these together. So what I'm doing all at once, I'm going to multiply these together, right? And that would give me
x squared minus x plus 6x.
is that right? X squared plus 5x? Well, if I did the whole thing out? Like, well, because like, I just did it together, because that's minus x, like you said, and that's plus 6, and, well, that would make 5, right? Minus 1?
I said it wrong. I was reading the one step above. It's x squared plus 5x minus 6, yeah.
Okay, so I did both of those things at once. I didn't show you the step, but we talked about it. I multiplied these together, that's here. And then I moved these two things to the other side, that's here. Now I need to combine like terms and then see if I can factor it. So I just got to clean this up basically, right? So I got x squared, that's no problem. But then I've got 5 and 3. That makes positive 2 because it's 5 minus 3, right? Minus 15. Oh, I think I know how this is going to work. Now it's easy. Like that's 5 and 3, right? Like you can factor that. So before I do, math is like dating. You got to take your time. So let's make sure we understand what we're doing. Not the individual steps, but like the big idea. So Ivan, we had an ugly thing like this right here, right? Mm-hmm. And we have to solve for x, which means we got to have something that says x equals this or x equals this when we're done, right? But in order to do that, we first have to get like a factor times another factor that equals 0, and we don't have that. Because when we have this, we have a shortcut. We can just take each one and set them both equal to 0. So we got to do a whole bunch of algebra before we can get a factor times another factor that equals 0. That's what we're doing. It's different depending on what's written. So we moved everything to one side, and then we multiplied, and now we're factoring. And I think that that's going to be 5 and 3, yeah? So this is one number times another number. This is one number right here times another number. The answer is 0. So either this number equals 0 or this number equals 0. And then we just have to figure out what are the numbers for x that would make that true. So x, if x was negative 5, that would work. And if x was positive 3, that would also work. Those are my two answers. Now, Alexa, here's what I'm going to do. I'm going to check. I'm not going to check them both because I don't want to spend a ton of time doing it. But let's pick one of these answers to check. Which one do you want to check? Negative 5 or positive 3?
Positive 3.
Positive 3. So what I'm going to do, I'm going to take positive 3. I'm going to plug it into the original equation and see if it's true. So let's do that. All right, so we've got 3 plus 6 times 3 minus 1 equals 9 plus 3 times 3. If this is all true, then that's a right answer. Okay? So 9, good, times 2, good, equals 9 plus, oh yeah, that's true, 18 and 18, right? 9 times 2 is the same as 9 plus 9. So that's the right answer. This isn't a step to help me get the answer. I'm just checking to see if I got it right.
I have a question.
What's your question, Alexa?
How did it go from this to that?
From here to here?
Yeah.
Okay, I did.
The last part.
You're good there.
Just the first part.
Right.
Like the 5x squared plus 5x minus 6. How did you get that?
This part right here, x squared plus 5x minus 6. Okay, I did two things at once. Okay, because I needed this. I didn't know that was going to be like what I had, but like this is what I needed. I can't do anything until I get there, right? Because once I got that, then it's easy. Okay, so I had to change this to this. So what I did is I multiplied these two things together, and that's right here. There's two parts, okay, but that's the first part. So.
But the 5 word, like multiplying, where does the 5 come from?
Well, because the outside is negative 1, the inside is positive 6. Do you remember the oi in FOIL? Remember? The oi is in FOIL, right? This is the oi right there. The outside plus the inside. Okay? Are you confident with that part? Okay, and then at the same time what I did is I subtracted 9 and I subtracted 3x from both sides, and that's where I got those right there. And then I just combined like terms. Yeah? Okay. One last glorious and wonderful problem for you wonderful people. It's this one right here. Is that right? Oh yeah, that's right. And that's it. This is the right worksheet, correct? Or the right problem? Okay. Now, same deal as before. That's got to be equal to 0 before I can do anything. So I can't it doesn't do me any good to factor or try anything until I get it equal to 0. So I need some ugly thing, blah, blah, right? Blah, blah, blah. Blah squared plus blah plus ugh. I need that equal to 0 before I can factor first. So I need to change this to equal to 0. So all I got to do is plus 12, right? Is that right? Is that good? Ooh, wow. Now I can factor. Look for a common factor first, just like always, right? See how you can divide an x out of everything? Let's take the x out of everything. So that's 7x squared, 31x más 12. Man, how do you like that Espanol? That's pretty fancy right there. Man, Edgar. Edgar. This is ugly because, oh, that's kind of tricky, right? Oh, I know it already. I got it.
Well, yeah, you're the math teacher.
Well, no, sometimes you get okay, it was my first guess. I just got lucky. I got my first guess. It's not because I have special math powers. Well, I do. I was bitten by a radioactive math spider. But I didn't use those. It was
You already know the answer?
I just guessed. But here's what I guessed. I'm like, okay, that's a 7, and that's 12, so it could be 4 times 3, right? And I'm like, well, 4 times 7 is 28. And then the 3's left over. Plus 3 would be 31. That's it. So here's what I was thinking in my head. 7x, I don't know where else you think. That was kind of a stupid statement. Here's what I was thinking in my head. I'll say, where else would you think? If not in your head.
Outside the box.
Oh, wow. That's true. Outside the bun. Outside the bun. You got to think outside the bun. All right.
You make things look so easy.
Well.
When they're not.
Okay. Alexa, I want to talk about that because I'm glad you said that. I make things look easy when they're not. They're easy to me because I'm really familiar.
Yeah.
It's not because I'm smart. I've done these a lot, and I know them. And so it's easy. You have a daughter, right?
Yeah.
Does she tie her shoes?
No, not yet.
But it's easy. You make it look really easy.
Yeah.
Well, she's going to be frustrated when you try to teach her to tie her shoes. There's nothing wrong with little kids. Little kids don't know how to tie their shoes. They have to learn. It takes lots of practice, right? With lots of practice and mistakes, that's how you learn, and then it becomes easy. So it is easy for me. That doesn't mean the math is easy. There's other math that other people make look really easy, and to me it's like, you're rude, because that's not easy. It's all relative to just where you're at and what you know. So, yeah, it's not easy. There's a lot of things to think about. And I've got so much experience, I know the stuff that would, okay, you have to make decisions. Am I going to think about this option or this option, right? Like when you're doing a math problem. Well, I've done enough of them that I know which one is like the wild goose chase. I know which one not to look at.
Mm-hmm.
So, yeah. All right, so anyway, even though you're mad at me because I figured this one out. Even though you're mad at me, do you see that that's true? Right? Because if I do the outside, that's 28, and the inside is 3. They're all positive. 28 plus 3 is 31. So now we have 3 numbers, 1, 2, 3, all multiplying, and they all equal 0. So that means that either x equals 0, that one's solved, that's easy, or 7 times x plus 3 equals 0, or x más 4 is 0. Take each factor, right? Set each factor equal to 0, and then solve them. That one's done. Thank you. This one's tricky, but it's just 2 steps. You subtract 3 first, right? 7x equals negative 3, and then you just divide by 7. There's your second answer. And then your third answer. Edgar, what, you got them all right?
Yeah.
Dang.
But I had to redo them twice. So the first try, I did the first try on the left side for each letter, and I didn't get it right. And then on the second try of each letter, I got it right.
Okay. No, there we go.
Yeah.
So, that's the idea. There's no, okay, there's a ton of practice problems in the book about this, and it's all the same idea. The thing is, you need to start off with some polynomial that equals 0. And then you factor. Right? So, step 1, you've got to get this. Some polynomial that equals 0. Step 2, you factor, and then you solve each factor. Each factor after you set them equal to 0. Just like we did right here. So these are the steps for all of them. This is the big idea. The like individual work will look different because the problems are all different, right? But get this equal to 0 first, then you factor it, and then you set each factor to 0, and you're done. Ooh, what?
Wow.
Yeah.